Welcome to your virtual classroom. This is Mansi Bhosle, your mentor for physics and maths. Hope all of you are doing well in this phase of lockdown. Last class, we studied certain situations wherein we had applied quadratic to solve real life situations, right? Now, one of the very most popular real life situation which normally comes in exam is to solve problems on boards and streams. Yes. So today we'll do certain shortcuts to solve problems, such type of problems. See now. And there are certain concepts that we need to relate, we need to understand when we have to solve upstream and downstream problems. Okay. So first of all, in water, the direction along the stream, we know the water flows from one, okay, the water flows like this. Now, the direction along the stream. So if the water is flowing like this, and if you're sitting, consider you're sitting on the boat, you're like here. Okay. Now, if you are going along with the stream in the same direction, this is always called as downstream, right? That means when you are sitting in the boat, you're going with the speed of the water, with the flow of the stream, that is called as downstream. Next, when you go against the direction of the stream of the flow, okay, when the direction against the stream, that is called as upstream. That means the river is flowing down and you are going up, right? That means you are going against the stream. That is called as upstream. Now, two things we need to remember. Obviously, when the water is flowing down, obviously there will be certain speed of water. Okay, so let this speed of water, or we call it speed of the stream, let the speed of the stream be v kilometer per hour. Okay, now when you go in a boat and when the water is still, that means the water is not moving, the boat will have some of its velocity, right? So now let u be the velocity of the boat. For example, this is your boat. U be the velocity of the boat in still water, u kilometers per hour. Two things we need to remember in this thing. When the boat is going downstream, that is when the boat is going along with the stream of the river, along with the flow of the stream, we need to add both. Because just tell me, if you are going towards, if you're going with the flow, both the speeds will add up. Your speed is u and the speed of the stream is v. So when you go downstream, both of the speeds will add up. So it will be u plus v kilometer per hour. Understood? When you go upstream, okay, when you go upstream, obviously you are going against the flow of the water. So when you go against the flow of the water, your speed will decrease. So your speed decreases to u minus v. That means your speed, that is the speed of the boat in still water, minus the speed of the stream. Understood? Only two important things that you need to remember. During downstream, add the speeds. During upstream, subtract the speeds. That's it. That is the only concept that you need to remember in these questions. Next, if they ask you, now if sometimes it may happen that if the speed of the downstream they have given, downstream speed they have given, if the speed downstream is like a kilometer per hour and the speed upstream is like b kilometer per hour. Okay, they have given these speeds. This they have given. These two they have given. Now, how to find the speed of still water? So in this scenario, the speed of still water will be half of a plus b kilometer per hour, right? And the rate of the stream will be half of a minus b kilometer per hour. Okay, these small two little things you need to remember and you'll solve the problem very easily. Now let us solve some examples. Okay, now question number 1 says Pratik takes 8 hours to travel 36 kilometer downstream and return to the same spot. So obviously this is the flow of the stream. Now the Pratik is traveling he takes 8 hours to travel 36 kilometers. So he is going 36 kilometer down and then again coming back 36 kilometer up. Okay, so this will be down, this will be upstream. Okay, return to the same spot. So this is the spot from, this is the spot from where he started. This is the starting point. Now the speed of the boat in still water is 12 kilometers per hour. Okay, so we need to find the speed of the water current. Okay, so now whatever is asked, let that thing, whatever is asked, let whatever is asked, what do we do? Whatever is asked, that is your x. Yes, the speed of water current is asked, so let the speed of water current be x kilometer per hour. Now what is given? Speed of boat in still water is given. So you written whatever is given. So given you have speed of boat, in still water is given, which is equal to 12 kilometer per hour. Now, what is the distance traveled? Now, as far as the formula for your speed is concerned, what is the formula for speed? We know that speed is equal to distance upon time. Now, what is given to us? Total time is given to us. That time from this point to go down and then again to come up. So this total time is 8 hours. So therefore, can I say that time over here is equal to distance upon speed? Yes. Okay. Now, let us write down speed in upstream and speed in downstream. So, speed when he is going down, speed in downstream, we know what the speed in downstream means. We need to add the speeds. So that means it will be 12, that is speed of the boat, plus speed of the water current. So it is 12 plus x kilometer per hour, and speed in downstream, sorry, speed in upstream, speed in upstream, we need to subtract. So it will be 12 minus x kilometer per hour. Okay, so now we got speed in downstream, we got speed in upstream. So total time taken. So now we know that time taken to go down plus time taken to go up is equal to 8 hours. Yes. So let us just put in this. Now we know time is equal to distance upon speed. What is the distance? Distance is 36 kilometers he has traveled downstream. So 36 upon 12 plus x plus 36 upon 12 minus x equal to 8. Yes. This is, we have got the situation. Now this we need to cross multiply. And let's find out, let's try to convert this into a quadratic. So now if I cross multiply this, this will be 36 into 12 minus x plus 36 into 12 plus x, the whole upon 12 plus x into 12 minus x equal to 8. Yes. So if you see the denominator, this denominator is a plus b into a minus b. So we know that goes into an identity, that is a square minus b square. And as far as your numerator is concerned, so the numerator 36 into 12. So it's 360 plus 72. So 360 plus 72 going to be 2, 12, 13, 1, 432. Okay. So over here 12 into 36 into 12, 36 12s is 432 minus 36x plus 36x plus 432 whole upon 12 square, so 144 minus x square equal to 8. So I'll transfer this over here, and if you observe 36 and this 36 will get cancelled. So now 432 plus 432. 432 plus 432 is 864. So this will be 864 equal to, this entire bracket goes to the other side, 8 into 144 minus x square. Now if you observe, this 864 is divisible by 8, so I will divide it to simplify. So if I divide it, I'll get 108 equal to 144 minus x square. Okay, so what do? We'll bring this x square to this side and 108 to this side. So what do we get? Minus x square gets converted to x square, so this is 144 minus 108. So that is x square is equal to 36. So now taking square root, we know x is equal to plus minus 6, right? But what is x? X is speed, and can speed be negative? No, it cannot be negative. So that's why we will discard x is equal to minus 6 and we will take only x is equal to 6. So hence we'll write the, you have to always give reason why you are discarding the negative value. Okay, so now hence speed of the water current is 6 kilometers per hour. Done. Okay, let's see one more scenario. Okay, over here they say a motorboat whose speed is 18 kilometers per hour in still water takes 1 hour more to go upstream than to return downstream to the same spot. Find the speed of the stream. Now again, whatever is asked, what is asked? Speed of the stream is asked. Let the speed of the stream be x kilometer per hour. What is given? Speed of the boat is given. So speed of boat equal to 18 kilometers per hour. Now, what is the distance traveled? Distance traveled is 24 kilometers. So 24 upstream, 24 downstream. Okay. So we know when it goes down 24 kilometers, it is going down. So both the speeds will get added up. So that means this will be 18 plus x. And when it is going up again upstream, it will be 18 minus x. Okay, so this is your downstream, this is your upstream. Okay, so let's write it down. Speed in downstream will be 18 plus x kilometer per hour. Speed in upstream, how does speed in upstream becomes? It subtracts, so it is 18 minus x kilometer per hour. Now motorboat whose speed, okay, he takes 1 hour more to go 24 upstream than to return downward to the same spot. So obviously, according to the question, they are saying that time taken to go upstream is more than time taken to go downstream. And how much it is more? It is more by 1 hour. So difference in time to go upstream and downstream is 1 hour. So can I say that time taken to go upstream minus time taken to go downstream is equal to 1. This is the thing. We know time is again distance upon speed. So what is the distance? Distance was 24 kilometers. So let us substitute. So it is 24 upon what is speed in upstream? Speed in upstream is 18 minus x minus distance, again the same 24 in downstream, but now it will be 18 plus x whole equal to 1. Now let us take LCM. If I take LCM over here, so this will be 24 into 18 plus x minus 24 into 18 minus x, and this is equal to 1. Entire thing again, 18 plus x into 18 minus x. Okay, now therefore this is 24 into 18. minus 24 18. So obviously this multiplication, so like 24, now instead of multiplying, just see if it gets cancelled or not. Plus 24x minus 24 into 18 minus minus plus 24x the whole upon, if you see, what is this, a plus b, a minus b, so that's a square minus b square, so it would be 18 square minus x square, and if you see this and this will get cancelled. Over here it's 1. Okay, this will go over here, right? So now what are we remaining with? We are remaining with 24 and 24. So 24 plus 24 will go 48x equal to 18 square minus x square. Yes, right? Yes. So I have done a prime factorization of 324 over here, and if we see that it is, if 3 2s are 6 and okay, can I say it's 54 minus 6 is 48, and 54 into 6 would be 324. Yes, so let's do this. So it's x square plus 54x minus 6x minus 324 equal to 0. So therefore x in bracket x plus 54 minus 6 in bracket x plus 54 equal to 0. X plus 54 x minus x equal to 0. So therefore either x is equal to minus 54 or x is equal to 6. Now, what was x? X is again the speed of the stream. Can speed be negative? No, it cannot be negative. So therefore, what do? We discard this value. So now we are discarding value. So therefore, we will take x is equal to 6 km per hour. That is therefore speed of the stream is equal to 6 kilometers per hour. Understood? Okay, let's do one more. Okay, the question says a boat moves through the water at x kilometer per hour. Okay, it is given as x. It makes a journey of 20 kilometers upstream against a current of 3 kilometer per hour and returns with the current. How much fast the boat must travel through the water in order to complete the trip in 5 hours? So that means entire time taken is given as 5 hours, and the speed of the boat we have taken it as x, and speed of the stream, that is speed of the current, is given as 3 kilometers. Okay, let us just note down what all is given. Speed of boat, assumed it as x kilometer per hour. Speed of the stream, that is over here it is given as speed of the water current, is given as 3 kilometers per hour. Total time, so total time, that means time to go upstream plus time to go downstream. Total time is given as 5 hours. Yes, 5 hours. Now according now to what will be the speed in upstream? Yes, speed in upstream, what does it become? Speed in upstream is subtraction. Okay, so it will be x minus 3 kilometer per hour, and speed in downstream, it has to be an addition, which is x plus 3 kilometer per hour. We know again the same thing, speed is equal to distance upon time. So therefore time is equal to distance upon speed. So now we have this time to go up plus time to come down is equal to 5 hours. So now let us substitute distance. So what was the distance over here? Distance over here was 20 kilometers. So distance upon speed. So 20 time to go, speed to go up, x minus 3 plus 20 speed to come down, x plus 3 equal to 5. Okay. Again, what do we do? Let us take an LCM. So it becomes 20 into x plus 3 plus 20 x minus 3 whole upon x minus 3 x plus 3 equal to 5. Okay, so let us open the brackets. So it's 20x plus 60 plus 20x minus 60. The denominator is a plus b, a minus b, so it's a square minus b square, so that would be x square minus 9 equal to 5. Now if you observe the numerator, plus 60 minus 60 gets cancelled. Okay, so what do we have? We have 40x, this entire bracket, I'll shift it to RHS. So 40x is equal to 5 into x square minus 9. I know 5 and 40 are divisible with each other, so let us divide them. So it's 8x equal to x square minus 9. I'll bring these two terms over here. So therefore hence the quadratic becomes x square minus 8x minus 9 equal to 0. That is the required quadratic equation. Okay. After solving this equation, we get the values of x as either x is equal to plus 9 or x is equal to minus 1. Obviously, what is x? X is the speed of the boat. Can speed of the boat be negative? No, it cannot be negative. So we will discard x is equal to minus 1. Hence, what we are left with, speed of the boat is 9 kilometers per hour. That's your answer. Okay, understood? Great. Okay, coming up next, we have another interesting situation in our episode 6.3, that is water tap problems. Okay, over here we will be dealing with two types of water taps. One is small, one is big. Water is coming out of both of them and they are filling up a tank. So now let's see what is the total time taken, which one fills the tank more easily, the larger one or the smaller one. Let's see, we'll solve such type of questions in the next class.